Okay, hopefully you're now done solving triangles. It's a fairly kind of monotonous section. But now we'd like to look at applying trigonometry. So taking some of these real-world situations and creating a picture and solving for the information we're looking for. So question number 48. A whale-watching boat is stopped near a rock to look at some sea lions. Then it goes 95 meters due west to head towards a possible whale sighting. The captain points out a pod of whales, which the radar shows are 140 meters north of the boat. How far are the whales from the sea lions, and what is the angle at the rock, meaning between the boat's path and the whale's direct line to the sea lions? Answer to the nearest tenth of a degree. Okay, so there's lots of information here. Important piece, the first boat starts somewhere and it goes 95 meters west. Then from wherever they end up there, they can see some whales, or the radar shows some whales 140 meters north. So let's draw a picture for that first. Just a reminder, the compass, never eat shredded wheat or never eat soggy wieners. However you remember it, north, east, south, west. So if we started right here, this is where the rocks with the sea lions are. We then go 95 meters west. From that location, the radar showed that there were whales 140 meters north. How far are the whales from the sea lions? So that's this distance here between the whales and the sea lions. Let's label that with X, that's what we're looking for. And the second piece is, what is the angle at the rock? So that's here where the sea lions were. So between the boat's path and the whale's direct line to the sea lions. So this is the angle that we're looking for here, theta. So we're looking for two pieces of information, the distance x and the angle theta. We can start by finding the distance x, and when we know we have two side lengths in a right triangle, we can find the third using the Pythagorean theorem. So 95 squared plus 140 squared must be equal to x squared, square root both sides, and x is equal to the square root of 95 plus 140 squared. Calculating that, we end up with 169.2 meters. Okay, so now let's look at finding theta. So from theta, the information we were given was our opposite side is 140, and our adjacent side is 95. Opposite and adjacent are connected to the trig function tangent. So the tangent of theta is equal to opposite 140 over the adjacent, which is 95. And to solve for the angle, we're going to do the inverse tangent. So let's say theta is equal to the inverse tangent of 140 over 95. And you can stick that into your calculator and solve for theta, and you should get 55.8 degrees if I've done this correctly. Asked to answer to the nearest tenth of a degree, so that's what we have there. And there. So those are our two values. So just a reminder, you might need to use your compass, take some time in drawing the picture, and then labeling the information of what you know and what you need to find. 49. As Sam is driving, she sees a sign telling her that the road has a 7% grade. What that means is that it has a rise of 7 meters for every horizontal change of 100 meters. What's the angle of inclination of the road to the nearest degree. So we have this road going up on the top here. For every 100 meters that you travel horizontally, the vertical change would be 7 meters. And that gives us a 7% grade. But we're looking to find this angle in here, theta, the angle of inclination. So from our angle, we know 7 is the opposite and 100 is the adjacent. Set up a trig function that relates opposite and adjacent. So that's tangent of the angle we're looking for, theta, is equal to 7 over 100. To undo the tangent of theta, we need to do the inverse tangent. And we end up with theta is equal to inverse tangent of 7 over 100. And you can throw that in your calculator. Should end up with 4 degrees. For B, it says, if she travels 500 meters along the road, how much has she risen vertically to the nearest meter? A couple different ways you can attack this question. One would be using similar triangles. The other one would be to use trigonometry. So let's use trig. If she travels 500 meters along the road, so this is our road up top. We're looking to find out how much has she risen. We'll call that x there. And the value that we now know is that the angle of inclination is 4 degrees. So from our angle, we know that this is the opposite and this is the hypotenuse. So opposite and hypotenuse comes from the sine function. So sine of 4 degrees is equal to the opposite over the hypotenuse. And now to solve for x, we just have to undo this dividing by 500. So we multiply by 500 on both sides. And we end up with x is equal to 500 times the sine of 4 degrees. And after putting that in your calculator, you end up with 35 meters. On to question 50. An architect draws this diagram of a wheelchair ramp or entrance ramp for a building. Determine the length of the ramp. Round your answer to the nearest centimeter. So you're already given the picture. The length is this piece up top. From our angle, we know that the opposite is 80. And we're looking for the hypotenuse. So opposite and hypotenuse is the sine of the degree, 4 degrees, is equal to 80 over the unknown value, x. Equation solving, let's get our unknown out of the denominator, so let's multiply by x on both sides. And 80 is now equal to x times the sine of 4 degrees. Getting x on its own, we'll divide it by the sine of 4 degrees. And we get x is equal to 80 divided by the sine of 4 degrees, which we can do on our calculator. And we should come out with something like 11.47. Now what's our answer to the nearest centimeter? So we can just round this to be 11 centimeters. B says determine the horizontal distance the ramp will take up. So let's call that y. And if we're looking for y, that's our adjacent side that we're looking for. And we know the opposite was the given value. So opposite and adjacent is the tangent of 4 degrees is 80 over y. And same idea, multiply by y on both sides. And divide by the, I'll write that out again for you. Now we need to divide by the tangent of 4 degrees. And y is equal to 80 divided by the tangent of 4, which gives us 1,144 centimeters. For this example here, we have the tan of 4 degrees is equal to 80 over y. And after we did some work on it, we ended up with y is equal to 80 all over the tangent of 4 degrees. If you start to see, after doing a number of these and knowing why you're doing what you're doing, that there's a bit of a shortcut where you just swap these two, you can go ahead and use that. But I don't want you to just remember it. I hope that you understand it. So that's a few examples for you. I'll leave you to work on the rest on your own. Good luck.